So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 249, and in this video we make a fast little exercise based on this little code here which we talked in our last video. And for this purpose I prepared here some questions, and I want that you pause the video, try to answer these questions as good as you can, and then start the video again. So I will of course not pause the video. I will go now to answering these questions. I hope you did all the questions, and let's see how I answer the questions. So first of all, it says here, write your own code example with derived classes and structs. This is for experience, so that you create here, like I did, a class or a struct, and then keep in mind when you create it, you make a real code, not like they made a demonstration. They break all principles. They have bad naming, no comments, compact style, and all this kind of stuff you should avoid when you make your own code, right? You should make good naming, also descriptive naming, commenting, readability, and all this kind of stuff. The second thing is here important when you write your own code, that you also test this inheritance, of course, here, and create objects to see how this works with this access specifier. Here we have protected, perhaps we have one with private and public and so on. All right, I hope you did this, and now let's see about the other questions. So here it says why I can't do this. You can see I try to create here struct B, and the reason is no default constructor. We learned if a class have a non-default constructor, the default constructor is not constructed automatically by the compiler anymore. But if you have no constructor at all, it would be created by the compiler. So then let's go to the next question. It says here, what is the default access specifier of struct B? Public. Why is this public? Because it's struct. We know the default access specifier for struct is public, and for class is private, and that's very important because here it's not given the access specifier. All this code is here considered to be public. Very important. Also when we inherit later. All right. Then why I have access to n, and you can see first of all I create again a x object, which means x is a derived class here, child class. And then I try to access n, and you can see the reason why I have access to it is this one is public. I inherit here what? Public, because here is an invisible public access specifier. And when I inherit public from the public base, then it stays public, which means I have access. And very important, this place is outside of the class. That's why so public is important, that you differentiate public and protected. If this would be protected, for example, I could not access it outside of the class, but inside the class, for example, here in this body. All right, let's go to the next question. And it says here, why struct x got no inheritance access specifier and for what we needed. That is again the struct here, x. And we see there is no access specifier, and the reason for that is optional, because it is only then optional when you want to use the default access specifier. In this case, again, it's public. There is an invisible public. If I would use a class, in my case, it would be private. So careful about not using that. It's better all time just to use it to make it clear. For example, when I create a derived class, just write access specifier here and all the other places as well. It provides readability, so you have not to think too much. And let's go to the next question. It says here, do we need a virtual keyword in struct x? You can see we have here a virtual, and we need it only then when we want to share the base variable and functions, right? So let's go here to the right side. You can see we have here two different structs, x, y, but both use virtual b, which means they will only create one base parent class, and they will share the variable. Important is if they share this variable, the last one who assigns here a value of this variable, it will count. For example, this x assigns here n7, and then y assigns n1, then the y n1 would count because it was the last one, because they share the same variable. Very important that you keep this in mind. It's good when you try this also with your code, perhaps with your example code. And let's go to the next one. So it says here y struct x is using in the initializer list the constructor call, and can I use the body instead? So what is that? So you can see we have here struct x, and here's the body, and here is a default constructor, and here is the constructor call in the initializer list, right? This is our initializer list. So the question is now, okay, why they are using it here? First of all, a direct call from a variable a direct call to a variable from the parent class is not allowed. So for example, if I would try to access this int n here from this initializer list is not allowed. What it is allowed is to use a constructor, but interesting is you can access it with this in the body of the constructor. So if I try to access it from here and equal 5 here, it is allowed. So keep this in mind. Here you are not allowed to do something like this, but here it is allowed if you try to access the parent variable. But if you try your own variable, for example, if I have here any other variable in this structure, of course you can use here this initializer list if it's own variable, if it's his own variable. All right, that's I hope this is also clear. Test it a little bit, and important is also that you know here the difference about this access specifier. For example, with the constructor you can also get access to private or let's say assign private variables. Here you can't. That's the disadvantage about the body. You can't access parent private variables from this body here. Keep this also in mind. All right, let's go here one step further, and it says and can I use the body instead? Yes, you can the body instead, and like I said, it has advantages and disadvantages. So let's go on. Here it says constructor must be public all time, and that is new. No. With the derived class, we can make now a new access specifier for the constructor, which is protected. Let me show you this in my example. You can see I have here my base class, and I have here two constructors, public and now a protected constructor. Protected constructor means outside of this if I create a variable, I can't call this constructor, but my derived class, for example my hotel, could call this constructor here if he won't make a special assignment. For example, you make here a constructor, and in your constructor body you make here a special assignment which should be only able to do the derived class. You can see you can make here a little specialization with this one. All right, then let's go to the next class. The next question, sorry. And it says here constructor must be public all time. No, we said. And here, if protected and private behave with inheritance similar, why we need it? So you can see we talked about this one. So when we have here inheritance, here is our inheritance, and here can be private or protected. And private and protected will behave similar in the way that you have only access within the class. If it's private, all things becomes here private. Here only not the private one, that's still inaccessible, but the public becomes private, the protected becomes private, and you have access it in your derived class. So what is the difference here? The difference is, let me show you this again in my example here. You can see I have here 3 different access specifier, right? And in my second one, I have protected. And we learned the protected will change this behavior in the derived class, not here in the base class, in the derived class to protect it. So if I try to access, for example, this house number, it is after this one house number, I can access this with protected access specifier. All right, so far it's clear. But if I make here private, I still can access this public here in my derived class also, because private becomes public becomes private, and that is the meaning why I said they behave similar. But the difference is, if I would go here one more step, so if I inherit here one more step, so let's say another class here tries to inherit now from, not from house, from hotel. So if I would try to inherit from hotel one more time, then the other one would, for example, stay protected here, and private would be inaccessible. If I would go one more step further. Okay, I explained this with words, it's probably not so good, but I hope you understand it. And if not, just make an example here and you will see it. So in short, I wrote here, because when we inherit more times, private will get inaccessible and protected not. That's so the main reason, because if you inherit all time protected, the public one or the protected one will stay all time protected, this access specifiers, and you can have many childs and all time able to access it. But if you make one time private, you can access it one more time, but then it's end after this inheritance line. All right. I think that's all for this, and I hope you did better than me. I tried early, you can see I just throw in some informations, and yeah, we will continue in the next video, of course, here with our site. And if you have any questions or any comments, like all time, write in the comment section. See you in the next video. Bye, good luck, and like all time, have fun and never give up.